So this is our working model of our automatic smart street lighting system. The main components that are used here are the three IR sensors that are used to detect the object, and there are three LED lights that acts like street lights. And then I have used a 9 volts battery to power the circuit and a manual switching to turn on the circuit. And here at the top I have placed a LDR in order to detect the light or dark. So depending upon the light conditions, this LDR will switch on or switch off the transistor. Let's say that if it is dark, so this circuit should work. So this LDR will turn on the circuit. If it is daytime, or if the light conditions are higher, that is the ambient light is higher, then it should turn off the circuit. So let's see the working now. I will turn on the project circuit. So now you can see that the three IR sensors have been turned on. So I will bring an object here. I have a toy car, so let me bring it one by one so you can see it's glowing. Okay, in case I'll just make it move by itself. Right, so I hope you have seen how the object is being detected, and according to that, the particular street light is turned on. Let's say that if it is a day condition, so for a day condition, I'm just using a light. So you just note down what happens on the IR sensors when I focus a light on the LDR. So we can see that the LDR is turning off when I focus the light on it. You can see it better when I place an object over here. The first sensor, sorry. Okay, now the first sensor is turned on. I'll just focus the light on the LDR. You can see that the IR sensor as well as the LED lights are turning off. So if it is night time, it gets turned on. Same applies for any uh, lights. So here, okay, so this is how the project works. So I will explain how the switching happens in detail with the use of circuit diagram. Right, so thank you. This is the working circuit of automated smart street lighting system. So let's see the components that are being used here. So we are using three IR sensor modules and four transistors. So in that, one is BC547 or NPN transistor and three PNP transistors, that is BC557 transistors, and 9 volt battery and a switch and an LDR to sense the light or dark. Right, so now let's see the working of the BC547 and BC557 transistors. Coming to this NPN, that is BC547 transistors, it will turn on when this base signal is positive, whereas the BC557 will turn on if the base signal is negative or ground. So positive pulse will make the BC547 to turn on. Negative pulse or ground will make this BC557 to turn on. So this is the logic behind this BC557 and BC547 transistors. So let's see the connections now. So this 9 volt supply passes through this line over here, and then it passes through switch. Let's say when the switch is closed, this positive signal will be available through the emitter of the three BC557 transistors, as well as this VCC. to this VCC of this 3 IR sensor modules. So it will help this IR sensors as well as the BC557 switches to get the positive supply. But here we have the BC547 transistors that is used to complete the circuit. So this BC547 will supply the ground line to this 3 IR sensor modules as well as this BC557 transistors to complete the circuit to turn on. So let's see how it happens. So as I told, when a 9-volt battery is connected through the switch, the positive supply will be available over here. And it will be available to BC547 only if this LDR resistance is higher. So this LDR resistance will be higher during the night time, or when there is low light. This LDR resistance will be having a maximum resistance so that the 9-volt supply will be available through this line over here, and it will make a positive pulse or a positive signal will be applied to the base signal. That will help this BC547 to turn on. So when the BC547 is turned on, the electrons will start flowing through this negative side, through this emitter and through the collector, and it will be available to the ground point of all the 3 IR sensor modules, as well as the 3 LED lights for the cathode. All right, so now the ground is available, and so we need to complete the circuit for turning on the LED now. So that happens when the object is detected. Let's take it for the first IR sensor. So when an object is appearing in front of it, the negative pulse will be generated in the output side. So the negative pulse. So now this negative pulse will make the BC557 to turn on. So if there is no object sensed, so the positive pulse will be sent, so it will turn off the BC557. So when the object is there, the negative pulse will make this BC557 to turn on through this 1 kilo ohm current limiting resistor. That will help to complete this switch over here that will connect this emitter positive line through the collector. The electrons start flowing and it will make the LED glow through this 330 ohm current limiting resistor. So it completes the circuit to turn on the lights. All right. So now, in case it is daytime or the light intensity is higher. So this light intensity, when it is higher, it will make the LDR to reduce the resistance. So from mega ohms, the reduced resistance will be of few ohms. So now that will make the negative side of the 9-volt battery to be available at the base point of BC547 transistor. So as we discussed earlier, so when negative pulse is applied, it will make the BC547 to turn off. That will in turn stop the supply of electrons over here. So the negative electrons will stop flowing through this ground as well as this LED lights. So that will make the entire circuit to turn off. So this is how the circuit works. Thank you.